Percentage changes can be quite tricky to work out, and the main thing that confuses people is what you have a percentage actually of. So if I have something that is this size, and I've represented it by 5 blocks here, where 4 are orange and 1 is white, you could say that the orange blocks are 80% of the stack. You could also say, though, if they're 80% of the stack, then the white block is only 20% of the whole lot, right? But what if we didn't have the white block in the picture at all, and we were talking about the percentage of this stack? Now with this stack, because it's only made of 4 blocks, each one block is 25%, not 20% like it was. So if I add another block on and ask how much it's gone up by, it hasn't gone up by 20%, it's actually gone up by 25%, because this extra block is equivalent to a quarter of what was there before. So that of what was there before is critical in understanding what's going on. Now let's look at a question like this. A book costs $24 after, that's something to highlight, being reduced by 40%. So it's already gone down 40%, but not 40% of $24. 40% of what it used to be, which we don't know. So we need to find out what the price used to be, what was the original cost. So the big trap here is that a lot of people find 40% of this and try and add it back on. But we want 40% of the old amount. So the easiest way to do this is to use algebra and say, let's let x be the original cost. Now we don't know what x is, but we can write a statement about x and then solve it. All right, now the part that you want to do in your head is the 40%. Now if something's gone down by 40%, it used to be 100% of itself, didn't it? Everything starts out being 100% of itself. It's itself, so it's whole. So that original price, it was 100%, but then it went down by 40%. So what percentage of itself is left? Well, if you do 100 minus 40, you can do that part in your head really nice and easily and say, we only have 60% of it left now. Now, we have 60% left, and that's what it now costs. That gives us our statement to write. What percent have we got? We've got 60% of x. And how much is that? That's $24, right? So that's equal to $24. That gives us our equation. Now all we have to do is solve it. First step, 60%, it's probably the easiest way here is to change this into a decimal. You could go a fraction and say it's 60 hundredths and then 3/5. And if you want to, you can. We'll do that over here a second way. But 60% is 0.6. So if you can convert your percentage to your decimal, you're a long way there. Now, of, what sign is of? It's times, isn't it? Now, do I need to write times x? Or is there a quicker way that we can write it? That's right, with our algebra we don't need the times sign. If you've got 3 lots of x, we just write that as 3x, don't we? We just smush them together. So we can do the same thing down here and say, that's 0.6 x's, and that equals 24. All right, now when we're solving equations, if I gave you this one, 3x's equals 12. What's 1x? Well, 3 4s are 12, aren't they? So you can spot the answer. But if you couldn't spot it, what would be the method to work it out? Well, you're trying to get the x by itself. At the moment, it's been multiplied by 3. So what is it when it hasn't been multiplied by 3? How do we undo that? Well, to undo multiplying by 3, we just divide by 3. But you have to do it to both sides of the equation to keep it balanced. The 3's are going to cancel, which means x is 12 divided by 3, which we knew already was 4. But now we've got a nice method. Now, here, we don't have 1x, we've got 0.6 of them. However many you have, here we had 3, you can just divide by that number. And the beauty of that is that 0.6 divided by 0.6, well, anything divided by itself is 1. They cancel out, don't they? But it tells us what to do to the other side. Divide that by 0.6 as well. Now, as you come to do this section, you'll think, oh, gee, dividing by 0.6, that's a bit tricky. Is there any way I can make that easier? Yes. All we need to do is multiply the top and the bottom by 10 here. Why is that? Well, when I'm doing division, I don't really care what complicated number is inside here. Even decimals I'm fine with. But I really like to have nice, easy times tables out there. A number between, say, 2 and 12 makes it really nice and simple. So I don't want to divide by 0.6. I'd much rather divide by 6. So multiplying this by 10 just turns the 0.6 into 6. It just moves the decimal once, doesn't it? But to make up for it, I need to do the same to the top and the bottom of the fraction. So that tells me it's the same as 240 divided by 6, which you can write like that, or you could write like this, either way. And I know my 6 times table, 6 fours are 24, so 6 40s is 240. So that tells me that the old price was $40. At the end, when you get an answer, just think through if it makes sense. If it was $40 and it went down 40%, which is a little bit less than half, isn't it? Would it land on $24? Yeah, that seems right. It's gone down $16, which is a bit less than half, so it seems right. And always checking your answer like that is really important. All right, how could we do a similar... Oh, hold on, I said I was going to work with fractions to show you that it's just as easy. If you'd like to change that into a fraction, 60% is 60 hundredths, isn't it? And we need to multiply that by x to get 24. Well, if you're happy with fractions, you can do it this way if you like. Now, 60 hundredths is the same as 3/5. Now, if I've got 3/5 of x, if I want to get rid of a fraction here like fifths, I can just multiply everything by 5. So I can do 5 lots of this and 5 lots of that. That will get rid of the 5s, and I'll just have 3 x's here. And 24 lots of 5, well, that gives me 120. Now to get 1x, when I've got 3 of them, divide by 3, divide by 3, and I can see that x equals 40. Different way to do it. Similarly, not too much more difficult. All right, what if we had a similar question, but instead of reducing it, maybe it had been increased. Maybe the book has gone up by 40%. Same method. Think to yourself, what did it used to be? It used to be 100% of itself. It's gone up by 40%, so it's now 140% of what it used to be, x. And what is it now that it's gone up 140%? $24. All right, now let's stick with the decimal method. I think it's slightly easier. Now 140%, that's 1.4, isn't it? And I've got to multiply that by x to give me 24. What do I do next? That's right, I divide both sides by however many x's I've got so that they cancel. But whatever I do to this side, I have to do to this side to keep it balanced. Now, I don't like dividing by 1.4. I think it would be much easier to divide by 14, don't you? So I'm going to multiply that by 10 and that by 10. That'll give me 240 divided by 14. Now, before I go ahead and think what that is, I'm thinking, hold on a minute, I can halve the bottom, make it 7, halve the top, make it 120. That looks a lot easier straight up. 120 divided by 7. Now I've got 1 there, remainder 5. I can put a decimal point in here and some placeholder zeros. Keep the decimals lined up. 50 divided by 7, that's 7, remainder 1. 1, remainder 3. Now I can keep on going here for a long time because this one's not going to end. So how far do I want to go? Well, I'm doing dollars and cents. So let's just keep going until we can round it off nicely to cents. 7 into 20 goes twice. Now obviously that would keep on going. But if I want to round it off here, that 2 tells me that the 4 is going to stay a 4 and not go up. So the original cost would have been $17.14. Now that's not exact, but it's to the nearest cent. So that's pretty much as good as we can get. And it's as good as you can get with a calculator just by doing these simple techniques.